In this particular question, which of the following diagram correctly represents the electric field between two charged plates if a neutral conductor is placed between the plates? So that means here in this particular case, what it is saying is that there are two neutral plates which are present over here, two charged plates which are present over here. One is positively charged and another one is negatively charged. Let's consider the below one is negatively charged and the upper one is positively charged. Clear? Just shown over here. So these are the cases: positively charged plate, negatively charged plate, negatively charged plate. So in all the four cases it is same. So when a neutral conductor, suppose there is a neutral conductor we are placing over here, and it is spherical in nature. Uh, so which field line is absolutely correct? So here in this particular case, one thing we must know that, as this is a positively charged plate and this is a negatively charged plate. Clear? When there will be no conductor in between the plates, then electric field lines will be straight. Here, when there will be no conductor in between the plates, assume that, suppose simply will be copying this one. This is the situation. So yes, assume that no conductor in between the plates, then the field lines will be from the positively charged plate to the negatively charged plate. Here, field lines will be from the positively charged plate to negatively charged plate. Here, so this is how the field lines will look like. But in the second case, it is said that when a conductor is placed, field lines will be like this. So this is wrong. This is not possible. And similarly, there is no question of taking option C, because field lines are shown parallel to the charged plates, which is again not possible. Field lines will be from positively charged plate to the negatively charged plate. Field lines will be from positively charged plate to negatively charged plate. Okay. So right now we are stuck in between option A and option D. So here in this particular case, one thing we must know that whenever we place any conductor in electric field, so electric field lines do not pass through the conductor, first thing. And when that means how they it means when you place electric field lines enter generally perpendicular to the surface of the given conductor. For example, here in this particular case, if this field line, if we try to draw the field line from here, this will enter perpendicularly. Clear? This will enter something perpendicular from this line. If any line will be coming, so it will enter perpendicularly here, and it will make 90-degree angle. Similarly, it will exit perpendicularly. Clear? And thing is that there will be no field line. Clear? No field line inside the conductor. Clear? Similarly, if any line will be coming from any other point, suppose from this particular point any field line will be coming, so it must go here, it must reach at this particular point. So that means that field line will move like this, so it will come like this. Here it will come like this. That means here it should be perpendicular to to the surface. And similarly it will exit from here, like this. Clear? This will be the scenario. Clear? Similarly, if any field line will be coming from here, so it is coming perpendicular to the given charge conductor, but after some time what will happen, it will enter the surface, it will come to the surface perpendicularly, and after that it will exit from the surface perpendicularly, and it goes to the charged negative plate. Clear? This is the situation. Clear? And similarly about the other cases, so this is something like that they will obviously they will something they'll parallel to each other. Clear? Here it is given, it has shown something other cases here, but some cases here, uh, uh, because as this particular region will gain, so as this particular end of the conductor, neutral conductor, is near to the positively charged plate, so it will gain some polarity, negative polarity. And as this side of the conductor is present near to the negatively charged plate, so this will gain some positive polarity. Clear? So positive. So some induction of charges will take place, and due to which what actually happens is that this field line will be attracted towards the negative charge. That's why they bend. And as there will be no field line, so when it exits and it goes to the uh, negatively charged plate. Similarly, this field line is when it comes, so it is attracted towards due to the presence of negative charges, induced charges, and again while exit it goes to the uncharged plate. Similarly, over here in this particular case, if we say that this field line when it comes, clear, this will be little bit attracted, so it will not come straight, clear, it will be little bit attracted towards the negatively charged induced conductors. And after that, as soon as it find the positive charge, positive induced charges, so it will again repelled, clear. That's why its nature is something like this, clear. So similarly, over here also, the field line actually it should come straight, but due to the presence of induced negative charges, it is bending towards the charge, and again due to the presence of positive charges, it is getting repelled, so that's why it bend like this, clear. So this is the scenario over here. So that means here in this particular case, option D, we can take option D will be the more appropriate answer, because in option A, these field lines are okay, no problem, but here it says that means nothing from where these field lines are coming. How can this directly these field lines will emerge from the given neutral conductor? So this means it is not possible. So option A is not possible.